Hi everyone, in this video lecture we will go through various methods that are used for the preparation of carboxylic acids, right? We will be looking both into aliphatic carboxylic acid preparation and aromatic carboxylic acid preparation, right? So first method that we will go through is from aldehydes, right, and your primary alcohols, right? Primary alcohols and aldehydes will undergo oxidation, right? So when we are saying oxidation, remember we need a reagent, right, to oxidize the secondary alcohol or your aldehyde, right? So the reagent that we will use here is your acidified potassium dichromate or acidified KMnO4 or alkaline KMnO4 or acidified alkaline potassium dichromate, right? So first method is oxidation of primary alcohol, and when we talk about primary alcohols are recognized by a group CH2OH, right, from primary alcohols and aldehydes. And if you just recall, we have done this in aldehydes in the reaction where aldehydes will get oxidized to carboxylic acid in the presence of Tollens reagent, right? If you remember silver mirror test that we have done while studying aldehydes, right? We have already done this reaction. So when we talk about aldehydes, just remember Tollens reagent, right? And also recall that Tollens reagent is a weak oxidizing agent, and that is why aldehydes can be easily oxidized to carboxylic acids, right? And the reagent that we would be using here in this reaction would be your acidified or alkaline KMnO4 or K2Cr2O7 potassium dichromate. Let's look into the reaction quickly. Let's take example of any generic alcohol, secondary alcohol, right? In the presence of acidified or alkaline KMnO4 or K2Cr2O7, right? Your primary alcohol, when we say primary alcohol, this primary alcoholic group CH2OH will get oxidized, right? And from the very basic definition of oxidation, we know that oxidation is removal of hydrogen or addition of oxygen, right? Just remember that. So here first removal of hydrogen will take place. This H2 molecule would be removed, right, and it will form CHO, which is an aldehyde. This aldehyde will further get oxidized, right, to change into your carboxylic acid, right? So this carboxylic acid formation goes through aldehyde. First an aldehyde will get formed, and oxidation is happening. You can see that one oxygen is increasing, so an addition of oxygen is taking place. So your aldehyde is oxidized to carboxylic acid, and your primary alcohol, which is denoted by CH2OH group, is again oxidized because you can easily see the removal of H2. It forms CHO, right? So let's take an example. Let's take example of CH3 CH2 OH, right? So here first it will get oxidized to, hydrogen will get removed, it will form acetaldehyde. This acetaldehyde will further oxidize to acetic acid in the presence of this reagent, alkaline or acidified KMnO4 or potassium dichromate, right? Similarly, if you want to prepare benzoic acid, you take this compound, oxidize it. CH2OH will first change into CHO, right? Two hydrogens are removed, so this is oxidation. This will further oxidize to COOH. This is your benzoic acid, right? This is your benzoic acid, right? So you just have to look at the CH2OH group. Before CH2OH group, this alkyl chain can be any. It can be like this also, a bigger compound CH3, CH2, 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 OH, right? So you just have to look at this CH2 OH group, right? It will get oxidized to CH3, CH2, CH2, then you have CHO, right? Now this will oxidize further into carboxylic acid, CH3, CH2, CH2, COOH, right? I hope this is okay, this is clear, right? You just have to remember the reagent, which is your KMnO4 or your potassium dichromate in this case, right? And remember, what is oxidation? What is getting oxidized is CH2OH, and then your CHO is getting oxidized. Second is your hydrolysis. Hydrolysis, alkaline or acidic hydrolysis of nitriles, right? When we talk about nitriles, it's this group, cyanide group. Compounds that contain this cyanide group are your nitriles, right? So let's take an example of a nitrile, CH3, C triple bond N, right? This will get hydrolyzed in the presence of acid or alkali. It will get hydrolyzed into CH3COOH, right? Similarly, if you want to prepare carboxylic acid, right, this nitrile, benzonitrile, will undergo hydrolysis, where this group, this CN group, cyanide group, will get hydrolyzed into COOH group. Right? This is your benzoic acid. Now you have to understand one more thing here, that how to prepare these cyanides. Cyanides are generally prepared from alkyl halides, right, or from alcohols. And let's just look at quickly the reaction. You have this ROH, it will react with trihalides to form RCl, right? RCl will react with copper cyanide and potassium cyanide to give you RCN, right? This is how you will prepare cyanides, right? So basically the starting material is your alcohol, right? And one more thing to notice here is that your alcohol contains one, in this case if you will see, it contains one carbon atom, right? If I start and do this reaction, your carboxylic acid contains two carbon atoms. So if you prepare carboxylic acids by this method, the resulting carboxylic acids will contain one carbon atom more than the parent compound. Here the parent compound would be, let's do it, CH3OH. It will react with, say, PCl3 to form CH3Cl. This will react with cuprous cyanide, right, to form CH3CN. Right, now this CH3CN will undergo hydrolysis in the presence of acid or a base, right, and will get changed into CH3COOH. So basically you started with one carbon atom, you ended carboxylic acid with two carbon atoms, right? So there is increment of one carbon atom. So this is one method. Now the other method that we will go through is from esters, right? Or let's do one thing. There's one more thing. If you have, this is your aliphatic cyanides, right? CH3Cl is an aliphatic cyanide. How will you prepare this cyanide, which is your benzonitrile? Benzonitrile is obtained from aniline by diazotization of aniline, right? And if you remember, the reaction would be, I take aniline, right? This will undergo diazotization in the presence of sodium nitrile and HCl. Right? And it will change into benzene disonium chloride, right? And benzene disonium chloride will react with your again copper cyanide or sodium cyanide, right, and give you your cyanide, benzonitrile, right, 273 kelvins. It will form benzene disonium chloride, N2 plus Cl minus, and this will undergo hydrolysis to give you, sorry, this will not undergo hydrolysis, we are preparing cyanide, so it will react with copper cyanide and potassium cyanide to give you Cn, right, benzonitrile. Now this benzonitrile will undergo hydrolysis to give you carboxylic acid. You just remember the starting product. How will you obtain this cyanide, right, benzonitrile, this benzonitrile. Benzonitrile is obtained from aniline, right, and aniline first will undergo diazotization reaction. This reaction is diazotization, where it will react with sodium nitrite and HCl to give you this salt, which is benzene disonium chloride, and this salt will further react with copper cyanide or potassium cyanide to give you benzonitrile, right, which will hydrolyze to give you carboxylic acid. I hope this is clear. Now we'll look into other method, which is your esters, right, preparation of carboxylic acid from esters. Esters will simply undergo hydrolysis, acid or alkaline hydrolysis, to give you carboxylic acids, right. So let's look into one example. Let's first this time look at preparation of aromatic carboxylic acid, right. It will undergo hydrolysis to give you COOH plus CH3OH, right. This is your benzoic acid and your methanol, right. This is your acid hydrolysis. I'm sorry, this is not your base hydrolysis. There's little difference in base hydrolysis. We'll just go through that. This is acid hydrolysis. In the presence of acid, your ester will undergo hydrolysis to give you benzoic acid and your methanol, right. And the name of this ester is methyl benzoate, right. Smaller alkyl group would be your prefix methyl, then this is your benzoate. Methyl benzoate will undergo acid hydrolysis to give you carboxylic acid. Now, if we do hydrolysis in presence of base, that reaction is known as saponification, right? And there you will first get a salt, which is a soap, right? Salt of carboxylic acids or fatty acids are called as soaps, right, which will undergo acid hydrolysis. The salt will undergo acid hydrolysis to give you carboxylic acid, right. So let's write down the reaction. So we'll take methyl acetate, right. It will undergo hydrolysis in the presence of base. In the presence of base, it will form a salt, which is a soap, right, which is the name of the salt is sodium acetate, right. It will form CH3CONa. This is your salt. Salt of carboxylic acid is your soap, right. And this reaction is, we call this reaction as saponification. Right, hydrolysis of carboxylic acid in presence of base is saponification, right. First it will form a salt, and this salt will undergo acid hydrolysis to give you acid, right. Now this will undergo acid hydrolysis, right, and it will form CH3COOH, right. This is simple. Now let's look into other method. This is important, just remember alkaline hydrolysis of ester is saponification. First it will form a soap, which is a sodium salt of carboxylic acid, which will undergo acid hydrolysis. In the presence of acid, it will undergo hydrolysis to give you carboxylic acid. Right? Now the other method that we will look into is from Grignard reagent. From Grignard reagent, and we know that Grignard reagent can be used to prepare variety of organic compounds, right? And carboxylic is one of them. So Grignard reagent, let's take RMgX, right? It will react with carbon dioxide, right? It will react with carbon dioxide in the presence of dry ether, right? First it will form an addition product. That addition product will undergo hydrolysis to give you carboxylic acid. It will form this addition product in the presence of dry ether. Make sure you understand why dry ether, right? Why dry ether is required here. We have done this before also, right? About dry ether, why we maintain dry conditions when we use Grignard reagent. The reason is, if Grignard reagent, right, will get any proton source like water or your alcohol, it will immediately change into your alkanes, right? So a side reaction will start. So as to prevent that, you maintain dry conditions. We take dry ether, right? There should be no traces of water, right, or moisture, because that will contain that contains protons, right? And protons will immediately react with Grignard reagent to form alkanes, right? So it will first form an addition product. Now this addition product will undergo hydrolysis in presence of hydrochloric acid to change into carboxylic acid, right? So we can look into an example quickly. C6H5 MgBr, let's say, right? In the presence of dry ether, it will form, right? And in presence of acid, this addition product will hydrolyze and will change into carboxylic acid, right? So this is how you will prepare benzoic acid from your Grignard reagent, right? This is your phenyl magnesium bromide, right? Just remember this addition product, then hydrolysis of this addition product to form benzoic acid, right? So now let's look another way. Fifth way, it's from trihalogen derivatives, right? Firstly, what are trihalogen derivatives? If this is your, say this is methane, if I reacted with chlorine, trihalogen derivatives, that means 3 halogen group will replace 3 hydrogen atoms to form CHCl3. This is your trihalogen derivative. So this trihalogen derivative will hydrolyze. Again, hydrolysis of this trihalogen derivative will take place to form benzoic acid. First, an unstable compound will form in which 3 OH groups will be connected to this carbon atom. And if you remember, we have studied this in chapter alcohols, that when you have more than one OH group, right, more than one OH group connected to carbon atom, right, this is an unstable situation. So whenever you have more than one OH group connected to a carbon atom, a water molecule would be eliminated because this is an unstable compound, right? So from this compound, a water molecule would be eliminated if you have 3 OH group. If you have 2, 1 molecule of water would be eliminated to form the resulting compound, right? So it will undergo hydrolysis right, with aqueous KOH. Right. Now this will undergo hydrolysis with aqueous KOH to form CH whole thrice. You have 3 KOH right. It will form CHOH whole thrice. Sorry. Right. It will form CHOH whole thrice. And whenever you have, as I said earlier, whenever you have 3 OH groups connected to the same carbon atom, right, it will undergo water elimination, right. So here you have 3 carbon atoms. It is this situation, right. So a molecule of water would be eliminated, right, and what it will form? It will form COOH. This is the compound that it will form, right, which is your carboxylic acid group, right. I hope this concept is clear, right. So it will form, here it will form this COH3, COH whole thrice will form COOH, and you have one hydrogen, so it will form HCOOH, it will form formic acid, right. Similarly, if we have, this is also trihalogen derivative which is obtained from toluene, right, CH3. So all hydrogen atoms would be replaced by chlorine atoms to form CCl3, right. It will again with KOH plus 3 KOH, it will form right. All chlorine atoms would be replaced by OH groups, right. Water molecule would be eliminated, because since 3 OH groups are attached to same carbon atom, so water molecule would be eliminated and it will change into benzoic acid, right. I hope this is clear. Just remember the concept of instability, right. Just remember that whenever you have more than one OH group connected to the carbon atom, this is an unstable situation and will result into elimination of water molecule, right. We have done this in chapter alcohols. Now we'll look into the other method for the preparation of carboxylic acid, right. The other method is your preparation from alkyl benzenes, right. When you have alkyl group connected to benzene, right. When you have alkyl groups connected to benzene, like this, these kind of compounds, right. You have alkyl group connected to benzene, it will undergo hydrolysis. This R group, doesn't matter how long this chain is, this is actually your side chain which is connected to benzene ring. So this side chain will undergo hydrolysis to change into COOH, like this, right. And you need a reagent for this. So the reagent would be alkaline KMNO4 alkaline, or concentrated nitric acid you can also use, right. Or the other common reagent that we use is acidified potassium dichromate, right. So you can also use K2Cr2O7 in the presence of sulfuric acid, right. So let's take example. If you take methyl benzene in the presence of KMNO4 acidified or alkaline KMNO4, or acidified or alkaline KMNO4, or K2Cr2 potassium dichromate acidified, it will change into this side chain, will form COOH, right. And suppose you have side chain CH3 CH2, CH3, then also it will form COOH. Right? I hope this is clear. Now suppose, let's say you have two alkyl groups. Right? Then both in the presence of these reagents KMnO4 or K2Cr2O7, both these will change into carboxylic acid group. Right? I hope this is clear. So aromatic carboxylic acids can be prepared by oxidation of alkyl benzenes. Right? Basically this is your oxidation. Oxidation is taking place. So here just remember that always whatever is the alkyl chain, this alkyl chain will oxidize to form COOH group. Right? Here also this is the alkyl chain, this is methyl, this is ethyl. So in both the cases this side alkyl chain will get oxidized into carboxylic acid group. Right? I hope this is clear. Now there is one more reaction from acyl halides, preparation from acyl halides. Acyl halides, you know, acyl halides is RCOCl. Now this acyl halide will undergo hydrolysis to form carboxylic acids, or acid anhydride will undergo hydrolysis with water. It will undergo hydrolysis with water to form carboxylic acid. Right? With base, it gets readily hydrolyzed to give carboxylate ion, right, which will undergo acid hydrolysis to form carboxylic acid. Right? Similarly, if you take acid anhydride, that will also undergo hydrolysis to give you carboxylic acid. Right? So carbox, if you take anhydride C6H5CO whole twice, right, it will form on hydrolysis with water. You have an oxygen here, C6H5CO whole twice in oxygen. Anhydride, you know, anhydride is obtained when a water molecule is eliminated from two molecules of carboxylic acid, right? It will form this compound. So anhydride, we know anhydride is obtained when a water molecule would be eliminated. So when water molecule would be eliminated from two molecules of carboxylic acid, it will form this anhydride, and it will undergo hydrolysis to form carboxylic acid group. Basically what you are doing is you are doing a reverse reaction. Anhydride is formed when water molecule is eliminated from two molecules of carboxylic acid. So what you are doing here is, to prepare carboxylic acid back, you are taking this acid anhydride and adding water to it. It will form carboxylic acid. Right? Now there is one more method, preparation from alkenes. Right? From alkenes. Alkenes will react, right, with carbon monoxide in the presence of steam. Right? This is steam. Under pressure. Under pressure to form carboxylic acid. Right? And there is one catalyst, temperature should be 563 to 573, and there should be a catalyst, phosphoric acid. It will form your acid. The acid that will get formed in this reaction is your CH3 CH2 COOH. Right? So you can take any other acid. Right? This is your 1, 2, 3. This is your propanoic acid. So if you take, say, CH3 CH2, right, what acid it will form? With carbon monoxide and water, it will form CH3 CH CH3 COOH under similar conditions. I hope this is clear. Right? So similar conditions, carbon monoxide in presence of steam, under pressure, in presence of phosphoric acid, which is a catalyst, it will form